Alright, so for law of cosines, I'm going to draw a coordinate axis here. Here's my coordinate axis. And I'm going to draw a triangle. So, and that is definitely not a right triangle. Why is that definitely not a right triangle? There's no 90-degree angle. In fact, it's got an obtuse angle, so it can't have a 90-degree angle. All right, I'm going to call this right here, I'll call this angle C, which means this has to be side C. And then I guess it doesn't matter too much. I'll call this right here angle A, which means this is side A. And this one I'll call angle B, which means that one's side B. Alright, and then I'm going to draw myself a right triangle. So I'm going to drop a perpendicular right here and make myself a nice right triangle. Like so. And I'll call that X, I suppose, and call that Y. What can you tell me about that angle right there? If I take that angle and add it with C, I get 180. That's what? Is that supplementary or complementary? And 180, so that's supplementary. You're right. Don't let me talk you out of it. What else can you tell me about those two angles? One is the reference angle of the other. Exactly. So this angle right here is an acute angle. It is the reference angle for that original angle. And what can you tell me about a reference angle and its original angle as far as sine and cosine and tangent go? They have exactly the same values, except sometimes you get a positive, sometimes you get a negative. All right, but this angle C here, this angle C is in quadrant 2. So sine is going to be exactly the same, isn't it? And what can you tell me about cosine? It's going to be negative. All right, so this angle, I'm just going to call it C again, although it's not really the same angle, but the important thing is the sine and the cosine really have the same values, except for perhaps positives and negatives, and we're going to take care of those positives and negatives here in just a minute. So, what can you tell me about the sine of this angle C right here? It would be opposite over hypotenuse. What's the hypotenuse? B. All right, so sine of that angle C is going to be opposite over hypotenuse, which means Y is B sine C. All right, and how about the cosine of that angle C? X over B, because it would be adjacent over hypotenuse. Exactly, X over B, which means X is B cosine C. So this point right here, this is the point X comma Y. That's going to be B cosine C comma B sine C. That's what we just showed. We just showed that X was B cosine C and Y was B sine C. All right, now what I want to do, I want to find the length of this side C. I know this point up in this corner, I know X comma Y. It's B cosine C, B sine C. What's this point right here? It's something comma 0 because it's right on the axis. What's the length of this? That's A. We called that A, didn't we? Okay, now how do I find the length of a line segment? You use the distance formula. What's the distance formula? Equals something squared. Yeah, there's squares in it. All right. So the distance formula says the distance squared is you take x2 minus x1 and you square them, plus y2 minus y1 and you square them. That's the distance formula. It's really just a fancy form of the Pythagorean theorem. But we won't go through why that's true. You just have to believe me. All right, so D. And so D, I'm calling this length C, the hypotenuse. Well, it's not really the hypotenuse because this isn't a right triangle. So we can't call C a hypotenuse. It's not a right triangle, but it's still C. So C squared is. Let's see the x values. The x values I have B cosine C minus A. And I'm going to square those. Plus the y values. I have B sine C minus 0. And then I square those. All right, I'm going to take this one, I'm going to FOIL it out. Take that one and just square it and see what I have. C squared is. What do I get when I FOIL this out? I'm going to have B squared cosine C squared minus the two middle terms. The two middle terms are going to be 2AB cosine C plus, I squared the last one, that's A squared. So that's the first one squared out. Now the second one, I can really just ignore the 0, can't I? So this one's just going to be plus B squared sine squared C.
Why don't you just say B cosine C squared plus B squared cosine?
Because if I'm squaring this, I've got to square both of them.
Okay.
It's like if I had if I had 2x minus 5 squared, I would do 2x minus 5, 2x minus 5. The first term would be a 4x squared.
Okay.
So I square the 2. 2 squared is 4, and I have to square the variable.
Okay.
So same thing here. B is just a number, so I have to square it. So that gives me B squared, and then I also have to square the cosine. All right, I'm just going to rewrite this a little bit. I'm going to write this as, I'm going to put the A squared first. Then I'm going to put these two together that have a B squared. So that's going to be plus B squared cosine C squared plus B squared sine squared C minus, and the only thing left is this 2AB cosine C. Anybody see anything special with these two things in the middle here? That's one of our, if I factor out the B squared, I'm left with cosine squared plus sine squared. That's one of our famous identities. What's cosine squared plus sine squared? 1. That's the Pythagorean theorem, Pythagorean identity. So we're left with, here's our law of cosines formula. C squared is A squared plus B squared minus 2AB cosine C. And that's known as the law of cosines. Notice it's almost the Pythagorean theorem, isn't it? C squared equals A squared plus B squared. Why do we have this minus 2AB cosine C? When does C squared equal A squared plus B squared? Only if it's a right triangle. Are we dealing with a right triangle right now? No. What if we did have a right triangle? What if C was a 90-degree angle? Would this still be true? I think so. Because if C is 90 degrees, what's the cosine of 90 degrees? Not 1. 0. So if C happens to be a right angle, cosine of 90 degrees is going to be 0, which means all this piece is going to disappear, and we're left with, and we're left with the Pythagorean theorem. So this even works if you do have a right triangle. More importantly, it works when you don't have a right triangle. All right, so there's the law of cosines, and it's written in 3 different forms. You could switch things around if you wanted to. Law of cosines. We have c squared equals a squared plus b squared minus 2ab cosine c. Or sometimes it's written as a squared equals b squared plus c squared minus 2ac 2bc cosine a. Or sometimes you have b squared equals, what would b squared equal? A squared plus c squared 2ac cosine b. So you see the pattern. If you've got c here, then you've got a c over here, and then you've got a's and b's in these spots. If you've got a b here, then you've got your angle b there, and you've got a's and c's in the other spots, so on and so forth. So if you know one formula, you really should know all 3 of them. You just permute the letters around. All right, so here's a typical problem you're going to see. Well, heck, I'll even draw a picture here. Here's a triangle. Let's see. Give me a number. How big is that angle? That angle looks like it's about?
110.
Oh, that angle cannot be 110 degrees.
I talked about that one.
Oh, you're looking at the other angle. The other angle could be 110. That one looks like it might be 30. Okay. And how about this side over here? How long is that? 10 units, whatever our units are, feet, miles, inches, that doesn't really matter. And how about this side over here? 8? Well, yeah, because it looks like it's shorter than that side, doesn't it? So 8 is a reasonable answer. 8. What do I want you to do? Solve the triangle, which means find the other sides. All right. Can we use the law of sines?
No, we don't have pairs.
No, we can't use the law of sines because we don't have a pair. Because the only angle I have is this angle. I don't have its opposite side. We could find the area of the triangle. That is true. We do have enough information to find the area. That's not what I asked you to do. All right. So let's give this angle a name. What angle is this? A, B, or C? This is angle A. Which means this is side A. 10, is that B or C? We're going to make that one C, and this one therefore is B. So this is our angle C, and this is our side, angle B. Which letter are we going to find first? Yes, there's only one we can find. The only one we can find is little a. Why is little a, at first, the only one we can find? Because I have its angle, and I have side B and side C. So we're going to use the form a squared equals b squared plus c squared minus 2ab, 2bc cosine of a. And again, these are really a lot of calculator work. We're going to have a squared is 8 squared plus 10 squared minus 2 times 8 times 10 cosine of 30 degrees. I'm going to grab my calculator and I'm going to type that all in. 8 squared plus 10 squared minus 2 times 8 times 10 times cosine of 30 degrees. That gives me 25.43 on and on and on. And then what do I need to do with that? square root it because I have a squared equals something. So I take my calculator, I do square root of that answer. A is, I got 5.04. We'll just call it 5. All right, so now we know A is 5. Now what do we do? Now I can find angle B or C. I can find either one. Which one do you want to do? And now we use the law of sines, exactly. Now we have a pair. Now we have a big A and a little a. Now we have a pair. Now we use the law of sines.
So it's cosine plus cosine sine.
No, you can use the law of cosines to find angles. We'll do one of those in just a minute. Now notice I could, if I wanted to, I could use the law of cosines again. I could use this angle C, and I could use A and B. I could use the law of cosines again. But typically, we use the law of cosines once, and then after that, we typically use the law of sines because we have a pair. Does it really matter? No. Truthfully, it doesn't matter which way you do it, but the typical way is to use the law of sines. All right, so if I'm going to find angle B, I would say sine of B divided by 8 is sine of 30 degrees divided by 5. And you might remember in past classes, I told you, if you can avoid it, you never want to use numbers that you figured out because you might have made a mistake. Here you can't avoid it. I have to use this number 5. I don't have a choice. So we use it. It's our only option. All right, so.
Do you want us to use the 5.04?
No, again, I would follow the standard. Since these were given as integers, we probably round this off as an integer. That would be the typical standard way to do it. So that's what we'll do. All right. So sine of B is, well, you know, this one's really nice because I know the sine of 30 degrees. What's the sine of 30 degrees? No, the sine of 30 degrees is not root 3 over 2. That's the cosine of 30 degrees. The sine of 30 degrees is 1/2, and when I take this 1/2 and multiply it by 8, 8 times 1/2 is 4. So this is sine of B is 4 over 5. Of course, there's nothing preventing you from using your calculator to type in sine of 30 if you want. All right, so I do my sine inverse thing. Sine inverse of 4/5. B is 53 degrees.
Then can we just subtract them both 180?
And then I find the third angle by simply subtracting. So angle C, the one we don't know, is 180 minus 53 minus 30. And my calculator says should be 97 degrees. Sure.
Why would we find two angles for B?
Excellent question. I only found one. Why did I only find one?
Because it was less than 1 and.
No, there's a good reason for that.
Oh, isn't that what the radio number
No. Look at the angle we haven't found yet in our picture. What can you tell me about that angle? It has to be greater than 90. So if this angle has to be greater than 90, can this angle also be bigger than 90? No, because then we'd have more than 180. When you do the law of cosines, you get one answer or you get no answers. You don't have to worry about the two answers possibility. That'll never happen with the law of cosines.
Can you do sine x over 10 and sine 30 over 5?
Absolutely, you could do the law of sines again if you wanted to.
No, like instead of like when you got to 5, doing sine x over 10 equals sine 30 over 5. Like instead of using the 8, use the 10.
Absolutely. Somebody told me they wanted to find B, so I found B. But you're absolutely correct. At this point, I could have gone sine of C over 10 is sine of 30 over 5, and I could have found C first that way. That would have worked. And then after you find C, you could go back and find B by doing 180 minus B minus A. Okay?
Yeah, I solved it and I got 90 though.
You solved it, you got 90. Well, let's see.
Like, I think I did it right.
Oh, yeah, that is weird, isn't it? I get 90 also. Because I would have sine of C is, sine of 30 degrees is a half. When I multiply by 10, I'm going to get 10 times a half, it's 5. 5 over 5 is 1. And that would have to be 90 degrees. So why do we get a different answer? Nothing's wrong.
You have 2 triangles.
No, we don't have triangles.
It's a 30-degree angle.
No, it has nothing to do with the 30-degree angle. It has everything to do with the fact that we rounded that number off.
Really?
Yes. Because we rounded that number off. Because that number really shouldn't be 5. It really should be 5.04. And then I'm going to have 5 divided by 5.04. I'm not going to have 1 anymore. So that's where it comes from. So that happens, unfortunately. Because you round off here a little bit, you can get slightly different answers when you solve later on if you solve differently than I do. So that can be a pain in the neck when I have to grade. Because if I find angle B first and then find angle C and you find angle C and then angle B, you might get different answers than I have. And so I've got to do it both ways. I've got to do twice as much work. Don't you feel bad for me?
You don't have to give the test for food.
I could just not give you a test. That's true. That's true. All right, so somebody asked, do you use the law of cosines to find angles? And my answer was, yeah, sometimes you do. I'm not going to draw you a picture this time. I'm just going to tell you that little a is, I don't care, somebody make up a number for little a. 10. Little b can be 4. And I need one more number for little c. 5. 4, 5, 10. Which angle do you want to find first? Big A? So if I want to find big A, I'm going to use little a squared equals b squared plus c squared minus 2bc cosine A. So if you're given all 3 sides, you can use the law of sines to find one of the angles. What do? Plug in all the numbers. All right, so I plug in 10 squared is 100, equals 4 squared is 16, 5 squared is 25, minus 2 times b, that's 2 times 4, that's 8. 8 times 5 is 40. Cosine A. Then what do I have to do? Add those together and then move them to the other side. All right. That's going to give me 59 equals minus 40 cosine A. So minus 59 over 40 equals cosine A. And I use that arc cosine thing on my calculator. Arc cosine of negative 59 over 40. Syntax, go to. Uh-oh. Oh, no, that's not a problem. My calculator says error. Domain. Quit or go to. Those are my options. What do I do?
Quit.
I quit. That's right. Darn it, I quit. Why do I quit?
Just re-put it in.
What's wrong with my calculator? No.
Because it's over 1. No.
What can you tell me about 59 over 40?
It's over 1.
It's bigger than 1. So if I do cosine inverse, can I do cosine inverse when I got a number bigger than 1?
No.
No, so what does that tell me? No such triangle. There's no answer. That's what that tells me. You guys picked bad numbers. That's what it tells me. All right, so let's pick good numbers. Let's repick.
1, 2, 3.
I was going to go 3, 4, 5, but I don't want to go 3, 4, 5. That's a right triangle, so we'll go 3, 4, 6. That won't be a right triangle. 3, 4, 5 would have been a right triangle. All right, so I'm going to do exactly the same thing. I'm going to use a squared equals b squared plus c squared minus 2bc cosine a. And again, I simply plug all my numbers in. 9 equals 16 plus 36 minus 2 times 4 times 6 cosine a. I take these two numbers, I move them over there. 9 minus 16 minus 36 is negative 43 equals 2 times 4 times 6 is 48, so negative 48 cosine A. I divide by the 48. 43 over 48 is cosine A. Am I going to get an answer this time?
Yes.
Yes, because 43 over 48 is smaller than 1. Cosine inverse of 43 over 48. Calculator says, let's round to 1 decimal place this time, 26.4 degrees. A is 26.4 degrees. Then we can use law. Could we use law of cosines if we wanted to? I could, but I think it's harder. I mean, I could go c squared equals a squared plus b squared, but I think it's harder to get this cosine c all by itself than it is to simply use the law of sines. So again, typically we use the law of cosines once. After that, we use the law of sines. So I'm going to go maybe sine of c divided by 6 is sine of 26.4 degrees over 3. So sine of c is 2 sine 26.4 degrees. Because when I multiply by the 6, I can reduce the 6 into 3. That reduces to a 2. Again, I grab my calculator here. 2 sine 26.4 is 0.88. And then I do my sine inverse.
It was a pretty good one.
When I multiply by 6, what's 6 divided by 3? 2. That's where the 3 went. I reduced it. All right, so using my calculator, I got C to be 62.8 degrees. Almost done. Now I know A, I know C. How do I find B? I could use law of sines, I could use law of cosines, or I could do the easy thing and say B is 180 degrees minus 62.8 minus 26.4. And my calculator says 90.8 degrees. Questions about the law of cosines?
So is there a way during law of cosine that you can tell whether it's going to be one of the answers or
Yes, when you use the law of cosines, there will never be more than one answer. That's how you tell. It's only when you use the law of sines that it's possible to get more than one answer. But we did see, with law of cosines, it is possible to get no answer. That can happen. Same way it did with the law of sines, you have a number here outside of the effective domain. Other questions?